Okay, hello again, and one last section to talk about, which is, of course, something very important. We have chapter 6 all about wireless networking, and we will not discuss wireless networking in another chapter, or we haven't already in the previous chapters. Then Wi-Fi security should also be mentioned here. So Wi-Fi security is about securing the data, your data that are flying in the air from the station to the access point, and that anyone can catch this frequency, this electromagnetic field, this channel that is broadcasting, streaming, or transporting data. Anyone can catch this one. Any hacker, any sniffer can catch it and see all the data inside it. Since it's about only modulation and frequencies, this guy can also take it from its device and can decode it again to zeros and ones up to the frames, packets, segments, application, etc. And that's it. Datagram, and can see whatever you are trying to achieve or do and steal all of your information. So subject 6.9, which is Wi-Fi security, to simplify it, it's all about securing the path, the wireless path from the station to the access point. That's it. Beyond the access point, there's other things. There's the wired network, and in the wired network it can't be catched easily, and just in case it was catched, then or sniffered, then other LAN security protocols to be applied upon this network. But just for the wireless network, it's about securing, encrypting the network from the station to the access point. Okay, but first let's talk about two things, which are unsecured and secured WLANs or Wi-Fi's. Unsecured Wi-Fi's or wireless LANs are the ones with no password, free and public, just like some Wi-Fi networks or wireless networks broadcasting or streaming in the street, hospitals, airports, hotspot in the coffee shops or restaurants, etc. Something that's free, public. By public, I doesn't mean it's streaming in a public place. By public, I mean that you remember SSIDs. You can hidden your SSID. Only some people are allowed to connect or see the SSID, not a public SSID. So when I say public, the SSID is the public one here. It's not placed in a public place. No, the SSID is the one that to be either to be hidden or public. So whether you have, in the case of you having a public SSID, free without a hosting and no password to connect, this is called unsecured wireless LAN, and since it's free, then everyone can see everything on your data. And secure wireless LANs might have, number one, a hidden SSID, just like the opposite of the public, some authentication before you can connect, which is this authentication can be some things that I will talk about, and some encryption for the data from station to access point, station client to access point only. Authentication and encryption are the things that I will talk about in this subject, the important things. Encryption is the big part of the thing of this subject, and authentication is a bit to talk about, which I believe authentication will happen only now. No, I will talk about authentication alongside with encryption for the entire until the end of the Wi-Fi security. So for authentication, basically authentication can be done by, number one, authenticating the user's credentials. When you want to connect to a station, it will ask maybe for a password, which is the passphrase. That should be enough. Or it will be on another way, which is captive portal. Captive portal is exactly like the hotels or the hotspots and restaurants, in the way that you can see there is a Wi-Fi signal when you search for using your mobile phone, your PC. You see some Wi-Fi signal, and there is no padlock next to it. There is no lock next to it, so you know that there is no password required for this network when you want to connect to. Okay, so since there is no password, you can just connect directly, but once you connect, it will redirect you to a web page, and inside this web page it will ask for a username and a password. This web page and this type of connection or authenticating is called the captive portal. Okay, so you will access a web page on the hotspot devices on the access points, and this web page you must type a username, a password, or sometimes you will ask for a 30 free minute of trial so that you'll test it. After that you will escape. No one will purchase. Okay, just in case you need it furthermore, or you will use another device with another MAC address. So these are two types of authenticating. The third type I have talked about before, which is authenticating a device's MAC address. This is when you also find a free network without any padlock, so no password is needed, and once you connect, you receive an internet. This happens inside your organization every day in the morning. Your laptop's MAC address is already authenticated by approving the MAC address inside the access point, or actually the controller would be better. It should be done from the controller, just in case you use the controller. And once you connect, you get connectivity. That's it. You're authenticated to access the network, okay, without any need for any credentials, captive portal, etc. So for encryption, that will take the rest of this chapter, some notes regarding authentication. For encryption happens. Encryption actually is securing your data, is encrypting your data, so that if someone sniff it, catch it, try to look at those data, he will figure out nothing. He will not be able to make any use of the data that he cached. So encryption for data frames only, not for management of frames. Management frames would get encrypted. And by management frames, I mean the frames that are sent between the station and the access point, that are saying that should I allow this guy. These are not data. These are something that happens only between the access point and the station. Should I allow him for accounting? Is he allowed to stay for 30 minutes for a trial, or for 24 hours, like in one day? Any other thing, maybe should I keep him signed, or should I kick him for some reason, kick his MAC address for some reason? These are some of the management frames. Those are not encrypted. They can't be catched and someone can read, oh, someone is to be kicked out, or maybe this frame, or can emulate this frame to kick out something, or to grant someone a 24 hours of access. These are management frames. Data frames are data. The data that you are using, a web page, a mobile application, etc. Those are data frames, are encrypted. Major frames are not get encrypted. So encryption happens between station or client and the access point only. I've talked about this before. What's beyond the access point, the LAN is not encrypted. I've talked about this before. To have an end-to-end encryption, you need to use HTTPS. HTTPS will send a digital certificate between the first application that you are using and the end application that's facing you, and this certificate will be between the source and destination, just like I said, and thus the entire path will be encrypted. So by default, encryption happens only between station and access point, and just in case you needed more encryption, or you needed to make the entire path encrypted, you need to use HTTPS, and most of us uses HTTPS when you maybe use any website that has money inside it, any website that requires purchasing. So if you are purchasing from Amazon.com, eBay, some other websites, etc., the URL must be HTTPS, because if it was an HTTP, your information of transaction, money, bank account, about purchasing the money will be seen by any hacker or sniffer. It must be an HTTPS. And to encrypt data, for the default state of encrypting a data between station and access point, there is only one single encryption protocol that Cisco wants you to know in the CCNA. This encryption protocol is called the Wi-Fi Protected Access, or WPA. WPA, or the Wi-Fi Protected Access, is an encryption protocol that has two modes, depends on the design of your network, or the desire that you want, not just the design, the desire also. And at the same time, it has three versions: WPA, WPA2, and WPA3. We'll talk about the three of them, as Cisco wants you to know all about them and the differences between them. WPA is an encryption protocol that happens between the station and the access point to encrypt the data that are flying in the air, your data, and has two modes to be enabled in the access point when you want to enable WPA for encryption. You remember the packet tracer? You saw WPA2, personal and enterprise. This is what will happen right now. Personal, if you chose personal, what happens is that first of all, WPA will use the passphrase, which is a statically assigned password inside the access point, and whenever someone searches for the SSID of this access point and wants to connect to it, it will require a password, which is this passphrase. That's it. Okay, so this is number one. This is a password that you type every day every time when you want to connect to a protected SSID. Number two, WPA will use a 256-bit pre-shared key for encryption between the access point and the station. This pre-shared key is derived mathematically from the passphrase. So if you have a passphrase of 123 ABC 123, there is an algorithm that's called the inside of the device. That's the algorithm of the WPA to take this passphrase, which is 123 ABC 123, do some mathematical things upon it, okay, some mathematical treatments or modifications for this passphrase and generate an encryption key. This encryption key will be used between the two ends, the station and the access point, so that when some encrypted file flies in the air and reaches the access point will use the same encryption key to decrypt those data, take it back to a text plain data and send it through the wire to the switch to the wired network to the distribution system, the DS. This pre-shared key to achieve this mathematical modification, it uses two or three things, three encryption protocols or modification protocols. One of them is called the RC4, the other is called TKIP, and the third one is called the MIC. Those are some detailed security protocols that I don't believe you should know in the CCNA right now. They are for the security specialist guys, but this is what the WPA uses to encrypt data and generate this pre-shared key. Okay, for generating the pre-shared key, okay, we'll use the three of those. TKIP, what does actually TKIP does is that for every packet for generating, for generating the pre-shared key, this one is for all the old points or the new point. TKIP every packet with a unique key. No, TKIP provides every single sent packet from a mobile phone to an access point with a unique key. So to keep changing the pre-shared keys between the access point and the station every time that you send a new packet. This is for the personal tip WPA. For the enterprise, this is about the deployment of the WPA, how you want to deploy it, because right now you have seen we have deployed the WPA or enabled the WPA personal in the access point, and the only thing that it will does actually is to encrypt the data that are flying in the air between a station and access point and vice versa. That's it. That's all what we do. But if we enabled the WPA mode as an enterprise in the WPA, authentication will join encryption. Okay, so who changed this? Well, I didn't. That should be good now. Okay, so if we enabled enterprise mode for WPA or WPA1, actually it's called WPA, this will use 802.1x. 802.1x is the one that's used actually in switches when you want to use AAA. And this will cause your network to use a supplicant, an authenticator, and an authentication server. Don't panic from these three. All of these three, you know them already. Because the station right now will be called a supplicant in the perspective of the 802.1x. This is the supplicant. It will talk to an access point that's mounted on the wall. This guy is called the authenticator, and using a cable LAN, with my nose today, okay, it will go back through the switch to the AAA server, which is the authentication server. So the authentication server, the authenticator, and the guy here, which is the supplicant, which is the client. Okay, so your packets will be carried by using an EAP. This is a protocol, an encryption protocol called EAP or EAP. 802.1x will happen only between the supplicant and the authenticator, station and an access point. Same thing. The rest from the authenticator to the authentication server will be a radius or TACAX plus that I have talked about in chapter 5 with AAA, which are the servers that are responsible for authentication, authorization, and accounting. After the authentication is done, encryption will start. You see? So using the WPA for enterprise will enforce encryption authentication first between those devices. After that, encryption will start. Encryption is done by the authentication server right now, you see, not by the access point. This is the difference, which will give each client a unique key. So those are the big differences between or the main differences to know between an enterprise and the personal WPA or WPA1, but actually it's called the WPA. After the WPA is done, here comes the WPA2, has slight differences because it also have personal and enterprise mode. Okay, now it uses AES CCNP encryption protocol or utilization or encryption shared key creation or generating criteria instead of the RC4 plus ticket. Personal and enterprise. For personal, also use passphrase, same thing. Also use pre-shared key. Also the pre-shared key is derived from the passphrase, same thing. Also encryption happens from station to access point or client to access point, same thing. But it does support AES CCNP, and just in case your hardware doesn't support AES CCNP because it's new and it utilizes a lot of resources, RC4 plus ticket is still supported, so your device can still connect to an access point using WPA2, but encryption will happen using RC4 plus ticket. For enterprise, I have this thing that I have read about, which is in enterprise you can use 802.1x in the ad hoc mode. Ignore that, because if you remember, ad hoc mode was about connecting two laptops wirelessly. There's the access point, and where is the authentication, and I have no idea actually. Just in case the exam asks you what does the WPA2 give to the enterprise, it allows for an ad hoc, it allows for an 802.1x in the ad hoc mode. Maybe I will need to research furthermore about that or about how it's happening. Okay, this is the first thing. The other thing is that 802.1x in the WPA2 personal enterprise supports re-authentication. Re-authentication is that just in case for the first time for authenticating, you'll type a username, a password, and some loading time to access the network. If you went away and came back like in 15 minutes, your MAC address is still saved, other things are still saved, you will connect faster than the first time with a faster procedure, or maybe directly you'll connect because your credentials haven't been forgotten, or you will not be asked for authentication to re-authenticate again. So it supports re-authentication directly. This is slight differences for WPA2 than WPA1. And then comes the WPA3. WPA3, same thing, personal and enterprise modes are here. It supports something called enhanced open Wi-Fi, like airports. With WPA3, open Wi-Fi, open free Wi-Fi networks now are encrypted. In airports, you will find an open, public, free Wi-Fis that you can connect your mobile phone directly to it, or laptops, or whatever device you have, freely and immediately without any question, any captive portal, anything at all. You can just connect and that's it, you're connected, you have internet. Is that creepy? You can just check the details of the SSID and see the encryption protocol. If it was WPA3, then your data are encrypted and you don't need to worry. Just in case they were WPA2 or 1, your data are not encrypted. Watch out for that. Okay, this is number one. Number two, WPA3 also supports Wi-Fi Easy Connect, which is for Internet of Things, Internet of Things, Internet of Things. Internet of Things are the future where you have, maybe I haven't talked about this before, but I will talk about in chapter 7 mostly, is about having like your lights in the home, your fan, your air conditioner, your maybe other systems. All of them are smart and connected to the Wi-Fi, to the access point in your home, and you can control them remotely or locally from where you're inside your home and can access the access point, and through that you can access those devices and change them and shut them and unshut them. So even data that has been transmitted between them can be transmitted using WPA3, the frames of those IoT things. For personal and enterprise also, for personal right now, no pre-shared key, no more like WPA and WPA2. SAE protocol is now used instead. Okay, the derived key now is not related to the passphrase. No one will guess your password anymore, your encryption key anymore. It protects against offline dictionary attacks. Someone might sniff your data and save them, and in home it might start to sniffing them even more for deep dive with them, so you can find any important things, or maybe if there was no connection or later on he can maybe hack them. With WPA3 he can't do that. And also WPA3 personal uses the PMF, which is protocol management frame. This encrypts some management frames. You remember only data frames were encrypted before. With WPA3 some management frames can also be encrypted. Okay, not all of them but some of them. WPA Enterprise uses also PMF and use something that I could not understand, but just in case the exam asks you about, it uses a 192-bit minimum cryptographic security suite. It seems that this is some kind of maybe a set of tools for encryption, for generating some key encryption, something complicated. Actually, I had no idea about it. I tried to study it, but I couldn't have like figured a lot of time. But I don't think even that the exam will ask you about them. Just in case I know that the exam is asking for more details about this, I will add them in a separated video or in the comment below below this video. And that's it. That's all you need to know about WPA3, WPA2, WPA, encryption and authentication in wireless. And that's all you need to know on Wi-Fi security. And should I say fortunately or unfortunately? Let's say happily or fortunately. Chapter 6 is done. I believe it has been like 8 or 9 videos for Chapter 6. That's it. That's all you need to know fundamentally and basically as a CCNA engineer about wireless networks. I hope all of it was clear to you. Just in case anything wasn't, all of it wasn't, you can comment down below in whatever video that you would like. We can do our best to achieve it. And I'm also planning for the CCNP Encore this year, of course, maybe in June. This will have a lot of information regarding wireless, so we'll deep dive in wireless there. So maybe from now until that time, let's see what will happen with this war that we are seeing right now on this planet. Okay, so thank you all of you, really thank you again for watching. Thank you for reaching the end of chapter 6. One chapter left only for this new course, which is chapter 7, automation and programmability, and I hope that I will be able to publish this chapter next week. I'll do my best to do that because we need to end it this week in March, this month in March. It has to be end this month. Okay, so thanks for again for watching, and I hope to see you in the upcoming videos in the upcoming chapter, and goodbye.